batteries for sustainable future and all that stuff, and we save a lot of batteries in it. And important thing I wanted to you guys to know that this AI and machine learning, all these are just a tools. So we need to apply to a certain problem to solve the real problems. So the real problems are much complicated than learning these tools. So we need to use these tools to solve the real problems. And batteries do have certain problems to be solved using this machine learning AI models as well. So we can touch upon these topics through this talk as a real problem that we would see. And I can give some broad areas of how you can use your knowledge from the machine learning AI tools on batteries. Okay? Is it? I need some response as well, because I can't just speak to the screen and say.
Yes, sir. Yes, sir.
Let's make it more interactive, and you are free to ask questions. I'll be happy to answer them. Okay, so my name is Dr. Ganesh Madhavatula. I'm Assistant Professor at the Department of Chemical Engineering and Technology, IIT BHU, Varanasi. We know about global warming. We keep hearing about that. We studied during our undergraduate course or before that as well, and it is all due to emissions and carbon dioxide, SOx, NOx, nitrogen oxide gases. So this is the reality. It's not that in the future we will be able to see and all that stuff. It is the reality that our ambience is getting warm day by day. Our summers are beating the records previously set by previous years. So in the past, let's say it took 5,000 years to warm 5 degrees for this ice age and evolution of life from the ice age and formation of bioorganisms, then evolution of humans. So several million years, it is a process of several million years. In the past, it took around 5,000 years to rise increase in 5 degrees centigrade in temperature. But due to our intervention as humans, as an intellectual species on the earth, we unfortunately, along with our development, along with our quality of life, we also affected the changes in the ambience atmosphere, and we raised the rate around 20 times more. If it takes 5,000 years for 5 degrees in the past, now it is only taking 250 years to raise 5 degrees. So this is basically because of the pollution that we are causing through our vehicles, our home energy needs, our industry needs, our aeroplanes, all of them on power plants. So we are emitting a lot of CO2 in it. We realize this problem. It's not that, okay, we haven't acknowledged it. That's why India went to one of the COP meetings, conference of partners, I guess, participating countries. So we pledged that we will become net zero emission country by 2070. Net zero means, do you have any idea of what does net zero emission country? What does it mean? Any opinions?
There will be everything based on this battery. There will be no emission.
Okay, so by 2070 we are still, so we are still in 2024, and by 2070, I mean we still have 46 years, I guess. So if I'm not wrong, so in the 46 years we need to become a net zero emission country. That's what India pledged. What does it mean is that it's not completely carbon emitting. Stop. We are not going to stop emitting carbon, because in some areas, some industries, there is no way you can stop emissions of carbon in it. We will generate somehow during our cooking or something of that sort. What net zero emission mean is that, okay, you released 100 tons of CO2 from one source, then you also balance it by improving the technologies by that reduces this 100 tons through another mode, like growing trees or improving the technology that emitted CO2 at some other place. So we emit CO2 at some places which are unavoidable and absorb the same CO2 through another technology. So this is what net zero emission means. By net, we will balance these things. So we pledge to become that. We realize the impact that we are trying to do. We are doing this. As humans, we have air conditioners, room heaters everywhere that we can survive even in the hot conditions. But when it comes to biological species like fish, birds, animals, they do not have air conditioned rooms. They cannot suddenly change their body nature to the ambience. So they take many years to adapt to the surroundings. So this is causing our technology is born for us, but born for something other species. Because they cannot evolve biologically, they are becoming extinct for rising these temperatures, especially sea life with this. So in this, we pledged to become a non-zero emission country, and we also wanted to reduce. So 2070 is too long. We do not know who will be alive by then, and we cannot plan things. We will even retire by then, and we can't do that. So right now, as a short-term goal, by 2030, India also proposed to pledge to become a non-fossil fuel increase the non-fossil fuel capacity to 500 gigawatts. So because of these reasons, you see a lot of news regarding solar plant installations. Government is moving towards this. They are trying to achieve this target by installing several non-fossil fuel plants like solar, wind, biofuels. Non-fossil means crude and raw coke. These are non-fossil fuels. But if we can generate energy from some other sources like solar, wind, biofuels, biomethanol, biopetrol, which are sustainable, you can call them as non-fuel. And we wanted to generate power of 500 gigawatts by 2030. So this is the target, and that's why there are so many companies focusing in India on this. Currently, so in this larger problem about global warming, batteries play a role as well. So that is the only reason we are discussing batteries, and the talk was titled as Batteries for Sustainable Future. Batteries are not energy generation devices. They won't produce energy, but they are like intermittent technology that can store energy. So from the non-fossil fuels, if we can generate energy through solar, wind, tidal, and we need to, these devices are only can generate energy. They cannot store. Can we build a technology that stores this energy and provides to us whenever we need it? For example, if we have a peak of energy in the afternoon and doing nothing, that energy has to be stored somewhere. It has to be used in the night for air conditioning. It can be used in the early mornings or in the late evenings for transportation like high-speed electric trains, all this kind of. So we need batteries as a pragmatic solution, which has a storage mechanism. Okay, that is the reason we are getting a lot of importance for batteries. That's one thing. And we are now, you know that we have too many two-wheelers nowadays. We see them on the roads, four-wheelers, battery cars as our transport medium. So because of these technologies, we can also use as a grid backup support. With backup support using this battery. Because of all these sustainability goals, the demand for batteries could grow up to 260 gigawatt per year by 2030. Currently, it is around 20 gigawatt hour in this year, but it is going to grow exponentially or 10 times by 2030. And the market is around around $15 billion annually. So this is the kind of the growth we could see for batteries in the coming years in our lifetime, because in the next 6 years we could at least see this. So why is this number important? It can't happen. This growth cannot happen in air, right? So we need people to. There is a huge growth, potential growth. At the same time, for this to happen, we need people who can do this. So the estimates that around 35 to 165 jobs per gigawatt hour need to be created for this exponential rise in battery demand. So we are learning different tools and trying to get employment and try to serve our best to the country and do well in our life. And if you wanted to think of employment opportunities, batteries is also a good area. As 260, let's say it is estimated 260, now multiply by 35 or 160, and these many jobs per year we could create. Okay, and in these jobs, AI and machine learning tools also play a role. And let me discuss how that can help. That will help you guys to enable your future. Why only lithium-ion batteries?
Sir, one question.
Yeah, please.
Sir, whether there is some hazardous situation possible due to this battery? Because this battery is lithium or that is lead battery. So there is hazardous condition present.
That is completely true. Yeah. This is the problem. Yeah. Yeah. Please complete your question.
No, this much.
With technology, we get problems as well. Nothing comes without its side effects. And we as an engineers need to, or a scientist or science students or any background, we need to focus on how to mitigate those side effects and use the best out of it. For example, for LPG, we use LPG cylinders, and they have the fire hazard as well, but we keep them in every home, and we learn to deal with these LPG cylinders. We learn to deal with these hazardous explosive gases. Likewise, if we put our knowledge in a proper way and how to manage them, we can definitely exploit the technology available for our good use. So this is something I can give. You are perfectly right. But we should innovate the technologies that can allow us to exploit the technology for our benefit. So as in my research, I'm also focusing on how to prevent these battery fires as well. Let's discuss those aspects in the latter part of the talk, for sure. So let's come back to this: why lithium-ion batteries compared to other batteries? So lithium-ion batteries, we keep hearing about different technologies: supercapacitors, hydrogen fuel cells, and lithium-ion batteries. And if you see the diagram on the right, this is where it plays a role in terms of power density versus energy density. This graph is like energy density versus power density. What it means is that
the screen is not visible, sir.
Sorry?
Sir, your screen is not visible.
Yes, it is visible.
I think maybe some network bandwidth
from my side.
Maybe
yes, sir, yes.
The bandwidth issue. You may stop your camera, or I can stop. So this is an energy.
Sir, am I audible, sir?
Yes.
Sir, am I audible, sir?
Yes,
Sir,
you are
sir,
audible.
one thing just coming into my mind. So, sir, just few months back, we have noticed in social, like some electric vehicle, like two-wheeler, like scooty, just exploded on idle condition.
So reserve that question for you, because let me. I'll just go back.
Yes,
I
sir.
will definitely deal with that, because so it's a part of, okay, it's a part of my
Yes,
talk. I will come to that point. Okay.
yes, sir.
Mm,
Thank you.
in today's session. Okay. So here, this is energy density versus power density. Let me explain in practical terms what do they mean. We have a car, let's say Tata Nexon EV, Tata Punch EV. So energy density means for a given charge, how much range it can give if you travel at a particular speed. Whether will it give 200 kilometers, whether will it give 300 kilometers or 500 kilometers, because the battery is fixed in the car. So that range is dependent on energy density. Okay. Whereas power density, you have a car like Tata Nexon with 200 miles thing, and you have another competitor, let's say another company came with another car with the same 200 miles range, but it has a speed limit of only 50 kilometers per hour, and Tata Nexon can go up to 120 kilometers per hour. So here, that speed limit is something relevant to power density. How fast you can extract the power. Can you can you cover this 200 miles or 200 kilometers at 100 kilometers per hour, or only at 50 kilometers per hour? So, but the range is same, but the time or the rate at which you can extract that energy is what power density means. Okay. So when it comes to these factors of range and speed, lithium-ion batteries are doing fairly well compared to the other technologies. We have lead-acid battery here. It has less range as well as less speed, maximum speed. So lead-acid battery falls in this region. We have nickel-cadmium batteries, sodium-sulfur batteries. These are future technologies which are not still successful in commercial thing. So lead-acid battery plays a role with less energy density, less power density, and that is why so far until lithium-ion batteries came into picture, we could not think of a practical way of having a battery electric vehicle. Only lithium batteries have enabled this technology application because of high energy density, high power density. So lithium-ion lead-acid battery here, nickel-cadmium batteries here, and then valve regulated flow batteries here. There are other air compression system. There are different things. And here is the hydrogen fuel cell. It has higher energy density. We can travel longer range. Hi, can you hear me? Seems like I lost for a bit.
Yes.
Okay. So I will take my time, because we have 3 hours of time given to me to discuss about the batteries. We have plenty of time to go through every detail in this session. So lead-acid battery is poor in terms of our applications. And here is a supercapacitor. Supercapacitor can let us travel even at 200 kilometers per hour, 300 kilometers per hour. But when you place that in a vehicle, your range is limited to 30 kilometers, not to 200 kilometers. So this is what all about batteries. That is why we think lithium-ion batteries are playing a great role in the current energy market. And They have average energy density, average power density, average cycle life, and average cost. This average is good enough for us, you know. So we don't need too much high energy density. We don't need batteries that let us travel at 400 kilometers per hour. That's fine. 100 kilometers per hour is fine. So we have an average performance of lithium battery that can do the job. So that's why lithium batteries play a great role in our market. Here in this slide, I would like to show how these batteries charge or discharge. Okay, and for some reason I could not see your faces. This Gmail is of that type. If you lose me in terms of voice, let me know. So here we have an anode and we have a cathode. So anode is generally like graphite, made up of graphite electrode, and cathode is something like lithium iron phosphate. You see the formula here for iron chemical formula. Lithium iron phosphate is one of the cathodes. So when you combine lithium iron phosphate with graphite, which is graphite means pure carbon, you can generate energy or store energy using this movement of lithium ion. Initially, as you see, lithium will be already there in the cathode. When you charge it, it will force the lithium to come out of the cathode, and it lets these lithium ions go from cathode to the anode and store there for some time. Okay. When you connect the load, you see here it is indicating the charging, so that ions are going from it, electrons are going to that. And when you connect the load like electric vehicle during discharge, the lithium ions which were stored at anode will be released back and they will come back to the cathode. So this is how this battery works, and we get electrical energy stored and discharged. And one of the great features of lithium-ion batteries are that they are rechargeable. You can do this charging and discharging for several hundred cycles. That is letting us to use them in our batteries for good enough lifetime. So lithium, this is another schematic that goes from this lithium ion goes from cathode to anode. Okay, now I would ask a question.
Sir, I have a question.
Yeah, please.
Sir, whether there is some fixed condition, present that during the discharging, charging cannot be done, or during charging, discharging can be done?
It cannot be, because it's like moving forward and backward. Okay, we are traveling in the forward direction, and you suddenly ask me to stop and do that in the reverse gear. It is same as this. If you give me, it is same as that. So lithium is during charging, lithium ions are going from cathode to the anode. We are forcing them to going with that. So it cannot. Okay, I understand your question. For our mobile, okay. What's happening in the mobile when you charge and use it as well? That's what you are.
Yes, sir.
Right?
Yes, sir. And another point is that. Hello. Another point is that during we are using dynamo in our cycles to provide light. Okay. So due to the kinetic energy, it is just charging. Similarly, whether some mechanism can be applied so that the battery could be charged and it can also move.
Then for the second question, yes, it can be done. We have these generators, right? They generate energy and that can be stored and can be used. That is one of the wind turbine. If you look at the wind turbine, the motor rotates. It's something like a dynamo in it. It generates energy that will be stored in the battery that can be used. So that is my answer for the second question. When it comes to first question, so in the mobiles, when you charge it and use it, what happens is that whatever the current you are supplying the battery to charge, instead of battery providing the energy, the supply is providing the energy for you to use it in your mobile. So the current you input is allowing you to battery to charge and also good enough sufficient for you to use your mobile. It is not like battery is getting charged at the same time and discharging it for the use. It's not like a medium block. This is a parallel channel. That's how it works. Otherwise, if you look at if you look at the battery itself, it cannot charge and discharge simultaneously at the same time.
Sir, I have a concern, sir. So it is said that it is not good to talk over phone while it is on charging mode. Like I have left my cell phone during charging, and I'm just at the same time I have a call, so I'm attending the call and start talking. So what is the thing, sir? Actually,
so
please.
Definitely see. Here, charging means you are providing extra energy for the battery, right? And
yes, sir.
This battery, so it's not just a battery in our mobile. This battery will have some chip that controls how this battery can be charged or discharged.
Yes, sir.
Okay. So if the chip BMS, battery management software, is poor in some standard cheaper mobiles that
yes, sir.
which are not engineered well, it means that circuit can overcharge at the same time, overcharge, and that can lead to battery fires. It's like abusing a battery. For example, if you push something beyond its designed capacity, that may lead to fire. If this battery, we have flammable electrolyte in it, something like petrol. There is electrolyte in this lithium battery, and this electrolyte is flammable. That is one reason we get this explosion kind of fire.
Yes, sir. Yes, sir. Yes, sir.
So thank you, sir. You are having this flammable electrolyte at your ear and charging it. If something is a problem, then it would cause an issue, definitely. And it also depends on that chip that controls how this battery charges and discharges. There is a battery management software in it. So always be careful. I try to not to use mobile when being a researcher in it. So I always suggest this to all of you to not to use it while charging. Okay, let's move forward. And then, okay, I would like to ask this question as well before moving forward. You see these batteries vehicles charging for longer hours, right? 5 hours, 4 hours. Why can't they be charged in minutes? Why can't they take in 15 minutes or 20 minutes? Do you think why it can't be charged? Do you have this question? Here, okay, the point is batteries during charging involves certain electrochemical reactions. So you are providing current, but this release of lithium from one electrode to other electrode is controlled by certain electrochemical reaction. Okay, a reaction. This reaction happens at its own rate. It has a certain thermodynamic limits. For example, as a humans, we can run at most, we can walk around 5-6 kilometers per hour. Maybe if somebody forces us, we can run around 20 kilometers per hour. Okay, this is our limit. Suddenly, somebody asks us to run at 50 kilometers per hour, as if we were tied to a vehicle and asked us to run along with it. Can we manage? We cannot manage, right? We cannot meet the speed of beyond our biological limits. Likewise, these electrochemical reactions also have their thermodynamic kinetic limits. We cannot force these lithium ions from one electrode to other electrode beyond certain time. So they have to happen at a speed they can do it. So that is the only reason we will not be able to charge batteries so fast. There are new technologies, there are fast charging technologies which are charging the batteries in a minute. It means they have devised these electrode materials in such a way that they can release lithium ions faster than
the other batteries. It means an improved technology. It's not like humans. We are like, for example, somebody gives us some drug that lets us travel and beyond our. It's something like it's an enhancement in technology. People are working on such technologies to charge the batteries faster. It all. So if some battery cannot be charged, it is all because of the rate of limits of the electrochemical reaction. So you see there is a reaction at positive electrode and there is a reaction at negative electrode, and these reactions are the limiting constraints for fast charging and fast discharging of a battery. Okay, good. Let's go to the next point. We know that there are lithium-ion batteries, but in the lithium-ion batteries itself, like in our soaps, we have different flavors, different versions of feel we get out of our soaps. Likewise, in the lithium-ion batteries, there are several cathodes and several types of anodes. Okay, and this LCO. This LCO is a commonly used battery in our mobiles because of its safety compared to the other batteries and high energy density. And LFP, lithium iron phosphate, is another cathode that is commonly used as well for our station energy storage, or some cars people are now using it. However, it has, this is a cathode capacity, this is anode capacity, this is potential. LCO and LFP have a reasonable capacity range. Whereas there are other batteries as well, NMC batteries. If you now wanted to buy a car, check what chemistry of batteries they are using. Are they based on NMC batteries, or are they based on LFP chemistries, or something of that sort? These NMC batteries have high energy density. The cars made using these batteries will have a longer range compared to the cars made using LFP batteries. But why we prefer LFP compared to NMC? NMC are not that safe compared to the LFP. So this NMC, cobalt and nickel content gives high energy. At the same time, it also increases the chances of battery fires. Okay, and it also limits the charging limits. We cannot charge quite quickly. Whereas batteries with LFP chemistry, they will have reasonable energy density. They will offer us reasonable range. At the same time, they have less range only compared to the other thing, and they can be fast charged as well, and they can be used for longer time. And in India, sometimes in my state or my place, the temperature goes beyond 45 degrees. So during around that temperatures, compared to NMC, nickel, manganese, cobalt oxide batteries, lithium iron phosphate batteries are safer to be used. So they are stable in high temperatures and can be fast charged. The only disadvantage is they have less capacity compared to this. It means less energy density. And instead of 200 kilometers for the same car, they may offer only 120 kilometers if you use this. So these are the two different cathodes for two majorly dominant batteries in India compared to other batteries. And graphite, for anode electrode, we generally use graphite with 300 ampere hour per kg. There are other batteries as well. People wanted to increase the capacity of the full battery. Then they are working on pure lithium, pure silicon and graphite compounds there. So it is an active area of research. Whoever is in the battery research, they will do that. And they are not constant voltage sources. The battery, when you charge it, the voltage changes from 2.5 to 4.2 volts. That is a cell voltage. The cell voltage is some difference between cathode potential and anode potential. So here LCO is the cathode and graphite is the anode. The cell potential varies during charge and discharge. This is too specific. Maybe if you are not in my domain, you will have some time to understand. Next, Here, how these batteries are made, I would like to cover through this. So these batteries you see have a cylindrical shape, but when you look inside, you will have separator, anode, separator and cathode rolled together in form of jelly, and this jelly will be inserted in a battery. And these anode cathode are not like these sheets. Anode, cathode materials are just like our tooth powders. They look something like this. So what in companies will do, these powders will be made like an ink, and this ink will be coated on metal sheets. This is alumina current collector and sheet, and this is copper sheet. So this ink will be coated on it, dried and rolled, and these rolls then using separator. We need separator to avoid short circuit. Okay, we need something that avoids contact between anode and cathode. So we have cathode roll, coated one, and anode roll. In between we have a separator that separates but allows lithium ions going from ordinary pole to the electrode. We wind them together and we insert. This is how a structure of a lithium ion battery would look like. Then let me briefly introduce about my work as well. So I look into these aspects, how cell design can be improved using work in my research, how state of charge, state of health remaining useful can be looked into, how we can improve the safety, prevent fires using models. How can I find out my electric vehicle cost after 3 years of use? Can I use battery swapping? Can I use? Can I repurpose my batteries after end of use of in my vehicle to something else like backup to at home? So these are the things that I look into using different modeling approaches. I build tools to answer these questions. You know, state of health. Let's say you got a two-wheeler today, and they're giving 3 years warranty. 5 years warranty based on this state of health metric. Okay, so it cannot work beyond certain years as expected. As I just mentioned, inside the cell we have multi layers of anode cathode. In one single layer, if you look at anode cathode, they are made up of small particles. We have separator here. This lets lithium ions going from cathode to the anode and back to cathode through this. This is a permeable membrane which allows lithium ions to go from. And if you look at the material, they look like something like this, very close powder. But when you do it some SEM imaging, you will see a structure something like this. Let's stop here. If you have any questions, I can answer. Fine. Okay. One thing. Okay. Let me ask this question. We know that monkeys love bananas, right? So we have a big bunch of bananas and bought from the market, and there is a hungry monkey. Okay, there are 4 monkeys now, and there is a bunch of bananas. And if I ask you a question, how many bananas will be left after an hour? What will be your answer? Any rough ideas or anything of that sort? How many bananas will be left after an hour? Any thoughts? How can we answer this?
Nothing.
It is a complicated question, actually. That's true. We cannot answer it directly. But on what factors it will depend on? depends on whether the monkeys are hungry or not, first thing. If they are not hungry, they won't eat. Second thing, their mood, even though they are hungry, whether they want to eat or not, that's a different thing. And their physical strength as well. Some of them will be sturdy and some of them will be weak, so that they compete among each other. And one of them will eat a lot compared to the other. Okay. And then it's also about relationship. If they belong to the same family, they share. If they do not belong to the same family, they will compete. They will have different bananas. So if I ask how many bananas were eaten by each monkey, then these all factors will come into play, isn't it? Do you agree with that?
Yes, sir.
And you need to respond, otherwise I can't just speak through a monitor and go along, continue for the next 1.5 hours, okay? So now I change the question. We have a lithium-ion battery of initial capacity. Instead of capacity, I will say 200 miles initially it is giving. After 3 years, it may not give 200 kilometers per charge. It only gives 150 kilometers per charge. Or after 5 years, it only gives 100 kilometers per charge. Okay? Why its capacity, initial capacity is dropping with time is dependent on degradation mechanisms in it. So I call them as degradation monkeys instead of mechanisms, chemical reactions. So there are several degradation monkeys that reside inside the cell. As long as you charge, they wanted to take over and whatever the energy you supplied will be eaten by these monkeys or mechanisms. Now, if I wanted to ask a question, how much capacity will be left after a year of use? How many more years it would work? This is, I wanted to ask. I need to answer these questions. So these are the kind of questions I ask in my research. How much capacity left after a year of use will be like state of health? I wanted to find out. How many years it would work efficiently is also about remaining useful life. So I approach the question in different manner. This is the kind of research I will do in my lab. Okay, why are they important? There are two vehicles recently quite popular in the market. What will be the cost of my used EV if I want to resell? I bought it for 1,20,000 this year, but I wanted to sell it. Who would decide the price of it? Can we have a metric, a scientific way of evaluating the cost of it? Okay, instead of 3 years, can I get a warranty of 5 years for the same vehicle? What will be the insurance premium? How much we have to pay insurance for a used vehicle or a new vehicle? How can we ensure accuracy for these batteries? For example, on the first day, it is riding at 90 kilometers per hour initially. Later, you are just accelerating through that accelerator, right? The battery has to function the same way for that given acceleration. So there is a battery management software that converts this acceleration into speed. That software has to function well. Otherwise, we lose control of the vehicle, and that leads to fire and safety hazards. Okay. So how can we ensure that the models deployed on a vehicle using this battery management software are efficiently being used? My work will be of that nature. Would like to answer these questions. Generally, these mechanisms, these monkeys, I mentioned, are dependent on their behavior dependence on location. In Varanasi, temperature is around 41 degrees at that time. At the same time in Munnar, it's around 16 degrees. So temperature is a geographical location is one of the main factors for cycle life, and also depends on who uses that vehicle. Will it be used by a working professional like us who just goes there once in a day to office and comes back, or is it extensively used by a delivery agent? He keeps charging, discharging, doing that. He will deliver the goods within 15 minutes, 20 minutes. It means the user vehicle will be different. And the third factor is about how fast we charge. Do we charge once in a week, or do we regularly charge? Do we charge it in 5 hours, or do we charge it in 1 hour completely? Do we use fast charging station, or do we use home station? It also depends on those factors as well. And lastly, let's say you charge your two-wheeler in the night and leave charge it to 100%, leave it at 100% throughout the night, and in the morning you use that vehicle, and by the night it will be again to 10%, and you do this cycle. You charge it in the night, use in the morning. On the contrary, I use this way. I wake up early in the morning around 6. I keep it charging for 4 hours. I use it. I do this early in the morning. I immediately charge it and use it. So these charging habits also influence the lifetime of your electric vehicle. So these are the several factors that decides what the life of your battery. Okay, and the degradation mechanism, I tell you that there are monkeys inside it. When you look into the cell, there are several reactions. One of them is that this electrolyte reacts with charged electrode and forms some side product like corrosion. You see corrosion on the metal surface.
So what is the recommended procedure for charging? Means whether it is better to charge in night and leave it for a complete night, or it is better to use for less time period. For example, we are using laptops. So whether it is recommended to connect it and use that, or it is better to not connect a charger and use the laptop.
So this battery is so how to extend battery life? I have a slide here. It says that first thing, we cannot control geographical location, but if you can control the use of at what temperature you use it. Instead of 45 degrees, if we can live in another location which is around 25 degrees, that extends a lot of time. And regarding park at low state of charge, instead of 100%, if you want to go on vacation, you better park it, leave it at the vehicle at around 30% instead of 100%. Because if you leave at higher state of charge, that energy will be eaten by these degradation monkeys. So their role will be high when the battery is at high state of charge. Of course, if you are immediately using it, that's fine. But if you go on a long vacation and you leave your vehicle at 100% state of charge, then these degradation monkeys will start eating your capacity, and you will lose capacity lifetime faster than other vehicles. And other thing about whether you wanted to charge it in the night or in the morning, I recommend to charge it in the morning and use it compared to charge it whole night. Charge it in the night and leave it there. But it's a matter of convenience as well, right? So everybody wants to wake up at early morning, 5 a.m., 6 a.m. and do their things, but certain of us will not be able to do. It's up to a personal convenience. Likewise, it's a matter of convenience versus the economic benefit we would get it. So user, if you can change your habits, it's always good to charge in the morning and use it compared to charge in the night and leave it all night. Next thing, maintain the median temperature, and instead of charging when the capacity drops to 10% or 0%, you can keep charging when the capacity drops to 30% and charge it up to 70% or 80% instead of 100%. If you manage your vehicle by charging when it falls to 30% and stops charging when it reaches 80%, that will have a longer life compared to the charging, whether it is morning or not, you charge it when 10% or 0% fallen, and then you discharge charge it until it's 100%. Instead of that, if you maintain your vehicle charging at 30% up to 80% and stop it, and you keep doing this, that will have a more beneficial effect compared to the other one where you charge at 0% and up to 100%. So there are several ways of extending the cycle life, but it all depends on a human habit. Hope I answered your question.
Yes, sir.
So, there are several degradation monkeys inside that player.
What is the time of joining? Just left out. Hello.
Sorry, seems like I lost you in between. Did I? My network got disconnected. Hello. Can somebody answer me, please?
Yes, sir.
When did you lose me? When I discussed about models or any idea? Okay, I have shown few slides at the end. Have you seen all the slides?
Yes, sir. I have seen, but I think last 2 minutes I was disconnected.
I think yeah, there is a problem with all of us, and so have you seen these slides?
No, sir.
This one. Okay.
This slide was shown at the first part of presentation when Jagat sir asked some questions.
I think I was discussing for a long time and suddenly got disconnected. Okay, here battery fires happen due to overheating or discharge, overcharge, mechanical abuse. So, was this slide discussed previously? No, right?
No, sir. No, sir.
Sorry then. So here is how battery fires happen. You see a lot of fire happening suddenly. This is because before battery fire happens, the smoke will get released and the fire, we catch fire. Okay, if you have a battery here and it has some electrolyte in it, and that electrolyte will get evaporated during temperature and it suddenly catches fire. This is what happens during battery fire. Unfortunately, I did not know where I left you guys. Okay. So this can happen in multiple ways, these battery fires. So one, if you use the battery called thermal abuse, overcharge it, overheat it, and electrical abuse and mechanical abuse. Mechanical abuse is like some accident. If a battery catches fire, a vehicle catches fire during accident, that could be because of mechanical abuse, where there is a crush, battery gets damaged, suddenly it catches fire. In the electrical abuse, if you have a battery management software that is poorly designed, that lets you battery overcharge or over discharge, even beyond 100%. If you leave it charging, the BMS is not functioning well, then that allows current to be pumped into the battery, and that leads to overcharge. So that also can lead to electrical abuse. Maybe this is one major reason for battery fires during charging, because that battery management software is not functioning well, and during using while charging, that could be also one reason where it is not designed well. That also leads to battery fires and abuse. So all of these things will play a role in battery fires. It is not just one reason. And during battery charge, what happens is that there is a voltage profile here and temperature rise profile here. And if you see, voltage suddenly drops where the short circuit happens, where anode is in contact with cathode, and thermal runaway suddenly temperature will rise beyond limit from 25 to 500 degrees. So these are some aspects of battery fire that happen, and there are 4 stages of during battery charging, battery fire: stage 1, stage 2, stage 3, stage 4. Are we disconnected during that? Okay. 4 to 12 for 25. Okay, we have another 5 minutes for this session. And there are several process happen during the charging or fire, like metal ion dissolution, separator melting, short circuit, and this is the stage 4 where battery fires happen. So I use my models, physics-based models with PD equations in it. I look at it to electrochemical reactions, lithium diffusion, ion diffusion. I build models, and then I use those models to see how temperature is changing across, how charge discharge currents will vary speed. I will pause for now. If you have any questions, please let me know. I'm almost done. This is my lab. People.
Any questions so far? So what I do is I build models that look into electrochemical processes like charging, discharging, reactions, diffusion, ion, how lithium ions move from one electrode to other electrode, and build the models and look at it how temperature changes, how the batteries are degrading, whether there is a chance of thermal runaway. So this is what I do. Likewise, you can also use this AI machine learning tools to monitor the data of temperature, voltage, and current of different vehicles and build a model that warns the user that your vehicle is going to catch a fire if you continue to use in the same manner. So you can devise such tools. You can get jobs in this area as well as a data scientist or machine learning scientist to process the battery safety data. So this is in summary for today's my talk. Yeah.
Hello.
Yeah. Hi, Manoj.
Sir, I have one. I want to know the research area in the battery. Means how the computer science people can use the problems in the optimization for the battery, either for charging, optimal way of charging or discharging, or other open problems in the battery that require the optimization, or means the problem that the computer science student can focus on.
So actually, your discipline students can focus on tracking the monitoring the data. For example, there are thousands of vehicles on the road, thousands and lakhs of vehicles. And for example, Ola keeps monitoring the data of each vehicle. All these Tesla, they monitor the vehicle's data of voltage, current, temperature. And if you guys can build a model that monitors the data and see some anomaly in the data, okay, suddenly something is being abused, temperature is rising beyond the limit, the current is going beyond the certain limit. If you can build models, deploy them on a cloud that monitors, tracks the data and warn the system and manage the data, you can have the opportunity to do that kind of work as a data science machine learning person.
So there are any data set available for this battery related problem?
I think some of them are available, but they're not as clear as what we wanted. But because this is a property of a car company and two-wheeler, they wanted data. Nobody likes to use their own data for some research or other purposes unless it is anonymized. So there are resources, obviously, there are some papers, but there are not many plenty. You can think of a virtual problem and work on it. Generally, people would recruit CSC students do this job in companies where they have the access to the data.
Okay, thank you, sir.
hope this session is useful. I trying to make it quite general, as I'm not an expert in this. Yeah, AL and machine learning. Any questions? If not, I will take a leave and I wish you all the best and good luck for your future career. Seems like most of us just join this call, mute and do their work. No, is this what the trend is for this kind of? Or people pay attention? What do you think? I see some guys. I don't know because. Anyway, good luck. All the best.
Sir, there will be a second session also today.
No. So I'm not. I have thought enough for today, and I will not be taking the second session. So there is no second session.
Okay.
Please note this, and thank you.
Thank you, sir.
Bye bye.
Thank you, sir.
Take care.
Thank you, sir.
Welcome. Bye.
you.